Welcome back to the series. This is the second video in the KiCAD tutorials. We are continuing with the ESP drone project, and what I'm going to do today is basically show you how I would create my schematic. So I will go through how we can create a informative top sheet and a hierarchical design to keep the schematic as neat as possible and not to clutter it too much. So I'll be using a lot of the features that KiCAD provides to maintain a organized and informative schematic. So let's get started. Doing a well thought out schematic capture and a PCB design is not the only thing that will affect the performance of the PCBs that you're going to get. The PCB supplier will also have a massive effect on the performance. This is where PCBWay, the sponsor of this video, comes in. They are a fabrication house for PCBs, but they can also turnkey assemble your PCBs for you. They offer other services such as 3D printing, and getting a quote from them is very easy. You just fill in your details on their quote page, which is on the screen now, and they give you an estimate of the cost, and you can request a quote for assembly right there as well. And I do share my projects on here as well, so please check them out. A big thank you to PCBWay for sponsoring this video. Please check them out. They are a reliable and high quality supplier for PCBs. Just create like a title page or a top sheet which provides information to the reader about what this project is and what it's trying to achieve. So I'm going to give it a title, make it bold, and put it down somewhere here. I like to have a kind of an introduction section over here. I like a table of contents. Basically for that you need another text box afterwards. So page 1 obviously is the top sheet, and then page 2 might be something else, page 3 might be something else, but we'll fill that out as we go along. Then I like to have a little section for items that are not part of the bill of materials. So that might be like fiducials or some other detail that's on the PCB, or it might be some other items that are on the PCB but not part of the bill of materials. I mainly use it for the fiducials, but it just keeps it a bit more organized. And then lastly, I like to have a section for additional BOM items. Now this could be things like screws or casing or standoff, adhesive, or anything that you need for the PCB itself for assembling the PCB, but it's not necessarily part of the PCB design. So if you were to, let's say, need some standoffs for the PCB, obviously you can't add that to the bill of materials as a component. So you can create a component called standoff and give it all the parameters you need to order it, and then that can be part of your bill of materials. So that's what we can use this for. And then the last most important thing, I like to create a system diagram. What I'm going to do is go over here and draw a big block, and this is going to be for my system diagram. So obviously I'm doing the ESP32 drone project, which is this schematic over here. Now when you first look at this, it's hard to follow. Obviously you can read some of the things, but if you had a block diagram, that would make it a lot easier to follow in terms of what's going on in the schematic itself. So what I'm going to do is put down some text blocks over here. So we know we have a USB input. So we have our USB input. We know in the circuit we have a charging circuit, and our USB input goes to our battery charging circuit. Now if I want to create a right angle connection, you can see I can't do that at the moment. But if you click this button, you can. One of the things you may want to do is make this thicker. So obviously that's too thick. Maybe 0.5 is better. So I have my USB input going to the battery charging circuit. I'm going to fill out the rest of this, basically show you what I'm kind of going for. But then this just helps to highlight how the circuit flow is. So, what's going to where and what's connected in this circuit diagram. So when you look at this diagram, it should be straightforward of what you're looking at in terms of the circuit. Once you've done that and filled out all the information, obviously you don't know yet how many sheets you're going to have and things like that, you're ready to kind of start your schematic capture. And for that, what I'm going to do is have another section where we can have our hierarchical sheets. So in order to create hierarchical sheets, we basically need to go over here and add in a sheet. So let's say the first one, what we're going to do is call that power management. So power management, I'm going to put down the USB-C connector, the battery charger, and any other things that might be relevant to this section over here. Now I'm just going to create all the schematic sheets that I think I'll need for this project. So you can see now I've created my block diagram and added 3 additional sheets to the project. So the 3 additional sheets I've added is the power management, ESP32 and the peripherals. In the power management sheet, I'm going to include the 3v3 regulator, the USB input and the charging circuit, and any connectors that are associated with it. So you can see there's a battery connector over here, so that goes in here as well. Then I've got a ESP32 sheet where I'm going to put down the microcontroller and any components I need for the microcontroller itself to operate properly. This can include things like the crystal and debugging connectors or programming connectors, whatever you may have. And the final sheet is the peripherals. In there, I'm going to include the motor driver and the accelerometer. So the additional sheets that you can see over here, they appear down here. So I've got the power management, which is page 2, ESP32, which is page 3, and the peripherals, which is page 4. Now, obviously, I showed you before how to create a sheet. You just basically click this button, and then you can draw out your sheet. And when you do that, you've got an additional sheet in your schematic. For the block diagram itself, obviously, you would do this when you are planning out your circuit. So obviously when you're trying to decide what components you're going to use, what the system is going to look like, and this diagram basically develops as you develop the circuit. But in our case, we had a existing schematic that we were following. So what I've done is looked at the existing schematic and basically tried to make sense of it and put it down into a neat block diagram that makes the circuit easier to understand. So obviously you've got USB input, which goes to a battery charging circuit, which goes to a battery connector. The USB input also goes to a 3v3 regulator, which powers the microcontroller, the accelerometer, and the motor driver is connected directly to the batteries. You can see VBAT, and it's supplying this case here. And we have a USB to UART converter, which goes to our microcontroller. And we have a toggle switch, which is the on-off switch in the circuit. So very easy to understand the circuit and what's going on when you create a nice, easy to look at block diagram. And this is especially handy if you have a complicated project. Obviously, if you have a very simple project, I don't recommend doing this. I don't recommend having multiple sheets as well. And then finally, I've added a bit of a description for the project. I've added the table of contents. So you got the top sheet there. I'm going to fill in my contents page. So you see I've got 4 pages on this schematic. I don't think I'll need to add any more, so that should be fine. Don't have any additional non-BOM items at the moment, but if I do need them, then I'll add them in. And this is items like fiducials or any test points you might have, which obviously don't go onto the bill of materials, but will go onto this PCB. Additional BOM items are things that don't actually go into the PCB, but need to go into the bill of materials. So that might be things like adhesive or your solder you can put on there as well. The advantage of doing that is that if you're interfacing with a kind of a management or PLM system, then you basically can generate your bill of materials from here and import it directly into that system. So it's very handy. So you generally want some fiducials on your board if you are going to do a SMD assembly. So this is for the PCB assembly machine to detect where your board is in terms of its location. And you might want some test points where you can program the board or test various aspects of the board itself. This might be during the development phase of the project or during production. So let's add them now. So both test points and fiducials, we don't want them to appear on the bill of materials. In the KiCAD standard library that gets provided with version 8, it comes with test points and fiducials already included. So if you click on this button over here, which says add symbols, or press the A key on your keyboard, you basically get this interface, and this is where you can add your components from. So you can see I have a bunch of libraries that I've created myself for my own use. So just give you some examples. These are just all the capacitors that I have at the moment and basically capacitors that I've used for projects in the past. Now, the way I like to manage my library is with part numbers. So I create my own symbols and then I use the footprints from KiCAD. And obviously where footprints are not available from KiCAD, I'll have to make my own or download them from the manufacturer's website. So you can see basically I've got a bunch of capacitors here with their part numbers, a description. Now, if you go into the capacitor itself, you got a bunch of different criteria there. For example, you've got manufacturer, manufacturer part number, supplier, supplier part number, and package. Now, what that allows us to do is go into our bill of materials over here. And if you go to the edit tab, so show you that again, it's bill of materials over here. Click the edit tab, and over here, you would have all your components basically if this project had any components. So when we start adding components to the bill of materials, they will start appearing over here. So let me show you an example. So I'm going to go into over here. I'm going to go into my schematic. I'm going to press the A key on the keyboard. And I'm just going to take a random capacitor and just place that down here. And let me find a resistor as well as an example. So you see I've got 4 components. I go into my bill of materials. I go to the edit tab in the corner, and you can see I have these columns over here from my components. Obviously this is configurable for project, and you can create presets as well. I will go into a lot more details about managing your bill of materials in a future video, but the reason I brought this up is test points and fiducials that I'm just going to show you now. We don't want them to appear over here. So I'm going to go back into my schematic. I'm going to delete the components that I've added, and I'm going to add some components in here, and let's find a test point. You can see we've got a nice simple test point, and then we do have alternatives basically if you want to use them as well. So just go for the simple test point, put that over here, and when you double click on the test point, you can see all the information that it has. Now what you want to do is click this button over here, and that will exclude it from the bill of materials. So let's untick it for now, press OK. Now if I go to bill of materials, you can see test point 1 is over here. Now if I go back into here and click the exclude from bill of materials button, now if I go back into bill of materials, you can see that the test point is over here. But if I was to export this out, so you find a suitable location, press the export button and go to that file. If you open that file up, basically the test point will not appear over here. And we can try this with the resistors as well. So let me just show you with the 5K1 resistor. So go back to bill of materials and export, press OK. And now if I open that file again, you can see that the resistor is on the bill of materials, but the test point isn't. So that's what you want. You don't want the test point to appear on your bill of materials. Now this is a non-BOM item which you can put over here, or alternatively, and what I like to do is add it near where they're going to be connected. So let's say this is going to be connected on a 3v3 line, then I would add it to the regulator section where it's going to be. So what I'm going to include over here is basically the fiducials, which I want 3 on this board. Then you can include mounting holes. I don't need them to be connected to ground, so I'm just going to add them like this. I need 4 of them for each corner, and then I want them to be marked so that they do not appear on the bill of materials. And you can see they're already marked as such. So when you export your bill of materials, they won't show up. Now in KiCAD, the workflow is for me a little bit strange in that what you have to do now that we've added these components is assign a footprint. And to assign footprints, you go to assign footprint over here. So we have our fiducials and we have the mounting holes that we spoke about. So let's say I'm going to select fiducial 1, 2, and 3. I'm going to find the fiducial section on this footprints library over here, and then I'm going to go for 1mm fiducials with a 2mm mask, and that's going to be okay for me. I want to select the mounting holes, go to here and get a 3.2 M3 mounting holes for this and press OK. Now ideally for me, you don't have to do that step. So if you're going to use fiducials like this for all your projects, what I would recommend you do is, instead of doing what we just did, is go to your KiCAD main window, go to your symbol editor, and then in your libraries, what you can do is create a new symbol library. So file, new library. I'm going to call this EE Non-BOM and click the save button. So you can see we've got a new library over here called EE Non-BOM. And then what I like to do is pin the library so that it appears at the top and you get this star next to it. Now, what we do is we go to the test point that we had earlier. So it was this one, and we can right click this, press save copy as, and move it to our EE library test point. And then what I'm going to do is rename this to 1mm pad, 2mm mask. So basically what footprint I'm going to give to this. So I'm going to give this a footprint as a standard. So if I go back to here, you can see in my non-BOM, I've got this test point. And if I want to see the details of this test point, I can basically press this button over here. And this is all the information that's for this test point at the moment. And what I would like to do for this test point is basically update the description. So test point, 1mm pad, 2mm mask. Obviously we don't need a manufacturer or anything like that. All we need to do for a test point is click exclude from bill of materials and press the OK button. The value field you can leave as is because you can fill values in there. So if it's going to be, let's say, connected to a 3.3 line, then you can change the value to 3.3. So you get more information that way from the test point on the schematic. And basically you can use that information on your on your PCB design as well. So now that we've got this test point on our EE non-BOM library, which is over here, we can go back to our schematic. We can delete these. Well, I created test points, not fiducials. So let me do the same for fiducials as well. So I'm going to go into my fiducial and I'm going to update the description as I did before. Fiducial marker, 1mm pad, 2mm mask. Apologies, I got that the wrong way around. I'm going to save that, go back to my test point and make sure that I update the information for the test point that I created incorrectly. So basically you can rename symbols in here as well. So I'm just going to rename that to test point. Test points can have a pad size, but they do not need a mask. So I'm just going to call this test point and call it 1mm pad for now and update the description as well. Then we can look at the test point footprint later on. So let's go back to our fiducial. I'm going to click the symbol properties button again, click on the footprint parameter over here, click on the footprint parameter over here, and then find a fiducial, which you basically get a window like this. So let's look for the fiducial that we selected last time, which was 1mm pad and a 2mm mask. Double click that and press the OK button. And this basically, the information in blue is all hidden, so it won't be shown on your schematic. If you do want it to show in your schematic, you can go in there and click the show button. Obviously we don't need this. Press the save button. I'm going to update my test point as well at the same time. So go into my test point, go into footprint and look for a test point. See, there's a lot of options. So I'm just going to go for a 1mm diameter test point and just click OK on that and save that. So now if I go back to my schematic again, and this time we've updated a fiducial rather than a test point, is delete all of these, click add part and then search for fiducial. You can see the pinned library, which is the EE non-BOM, has appeared first, and we've got our fiducial 1mm pad, and this time you can see that there is a footprint already assigned to it. So you double click that. This value is a bit too long, so I'm just gonna change it, and I might go back into my library and change that as well. Now if you don't like the long description, obviously you can just get rid of it as well. So we've got our 3 fiducials over here with the relevant information that you need. I want to do the same thing for the mounting holes. So you can see on the screen I've basically created the mounting hole as well now. Now the advantage of doing this is if I go back to the schematic, these fiducials, they will have a footprint assigned to them already. So if I go to my PCB editor and basically show you this and load up update footprint, you can see they come in with the footprints already there. So what I don't have to do is basically go into my footprint assignment tool and assign footprints to them. And I like to do this for all my components. I think the footprint assignment should be done before you do your before you select the component in the schematic. So let's say, for example, you plan to use some component as part of your system. You should already know what footprint it is. You should already know what symbol it is. Therefore, I think you should already have that as an existing thing on your library. I think doing a footprint assignment like this, I think the chances of getting it wrong are higher, because one time you might assign one particular footprint, and then let's say you come to use that same footprint again for another project, you might assign a slightly different footprint, and it increases the chance of getting it wrong the first time round. And when you're designing projects for a business, you want to get things right the first time as much as you can. You want to avoid errors. You want to avoid delays to your project. Even for personal projects, it's just going to cost you time and money. So doing it like this, I think can, in the long run, be better for you. And obviously, creating components this way will save you time in the long run as well. Obviously, when you're doing it for the first time, that's going to cost you a little bit more time to get it all prepped. But once it's all done, you don't have to worry about it. Another thing, it gives you consistency. So in this case, I've set up a fiducial with 1mm wire and a 2mm mask. It's already set up in my library, but I'm more likely to use this fiducial for future. I'm less likely to go for a 2mm pad, let's say. It just prevents things going wrong. But that's everything we need to cover for today's video. So hopefully you found that useful. Just to recap, what we've done today is basically we've created our top sheet. We've kind of figured out how many sheets we need. Obviously, we can expand that at a future date. So in this case, we've gone for 3 worksheets that we're going to use. One for power management, one for ESP32, one for peripherals. We've done a nice little diagram for our system that we're designing. And obviously this would stem from your kind of product requirements. In this case, we're following a existing schematic. I've kind of just reversed engineered it really, but you would start with your requirements and develop your system diagram that way. I've added a bit of a description over here for the schematic. I've added a table of contents. I've added non-BOM items. In additional BOM items, you can basically add in, like for this project, for example, you can add in the motors, the battery, any other components that you might need. And the way I would recommend you do that is basically creating new components in your library. So what I would do is how we created non-BOM items library. You can create a BOM only library for your components like that. And you basically make a motor symbol and add in parameters for the motor, like where you're going to order it and things like that. Most likely for this project, I'm going to order the motors and the fan from AliExpress. When I do the library management in a bit more detail, I'll show you how I do that as well. So thank you for watching today. That's all I have to share with you, and stay tuned for next time where we will basically start doing our schematic.